there, good to see you. Hope you're all ready for some maths. It's Miss McDonald here, and today we are using formula. This is also known as substitution, and it's exactly the same as when you're talking about substitution in football. You're taking one thing out, putting another thing in its place. So we're going to be taking letters out and putting numbers in their place. First up, a nice easy one. So this is how to actually make pasta. I don't know if you've ever tried to make pasta before, but it's really difficult to get the right amount. So here is the formula, or what you need to make the formula for pasta. So if you're making pasta, you should have 50 grams of pasta per person, plus one portion for the pot or for luck. So you just throw an extra little portion in there, just in case. I don't know, everyone's hungry. So let's make a formula for that. So the way that this would be read is the weight of pasta that you need is equal to 50 times the number of people that you've got, plus 50, that's our extra portion there. So one of the main mistakes that people make when they're doing substitution or using formula is not recognizing that if you've got a number and a letter right next to each other, that is a multiply. So say for example, we had 4 people who wanted to have pasta. How much pasta would we need? We are going to substitute in that we've got 4 people in here, and it's not going to become 504, it's going to become 50 times 4. So I show my working like this. And then finally, I can use a calculator, or can probably just do this one in my head and get an answer. So for 4 people, you're looking for around 250 grams of pasta. Let's look onto this one here. This is converting Celsius to Fahrenheit. Have a read of the formula. It says if you do 9 times the Celsius divided by 5 and add 32, that will give you the Fahrenheit. So 9 times the Celsius divided by 5, add 32 is equal to the Fahrenheit, which we're looking for. And I would encourage you, if you are coming up against a formula, if you read it with the words in it, Celsius, Fahrenheit, and what you're doing, it's basically just a set of rules, of 7 instructions on how to get your answer. Today, it is 7 degrees outside where I am, and that's 7 degrees Celsius. I want to convert that into Fahrenheit. You can pause just now and have a try, and remember to show all of that working. Okay, let's substitute in. So I'm going to take C out, and I'm going to put 7 in its place. So I'm going to have 9 times 7 over 5 plus 32. And let's find out what that gives me. So 9 times 7 is 63, and then if I divide that by 5, it'll give me 12.6, and then I'm adding 32 for a nice 44.6 degrees Fahrenheit. Okay, really, if you are aiming to do your units in applications of maths, that is as far as you need to go when it involves substituting into a formula. This is a C-level question, and if you can do this, then that's all that would be asked of you in a unit assessment. But there's some really interesting formulas that I'd quite like to show you. I took everything from real world today. So if you feel like doing a little bit more, a little bit of a challenge, or heading towards, exam level prep, you can watch on. I've got 4 more examples that come from real world stuff. So first up, we've got BMR, which is your basal metabolic rate, which it basically means if you were to sit all day and do absolutely nothing, how many calories would your body burn by just doing nothing? Being alive, just your regular, daily functions, your lungs working, breathing, all of your organs working, that takes calories as well. So if you were to do nothing other than just be alive, how many calories a day would you be burning? Well, there's an equation for this, and it's called the Harris-Benedict equation. People have adapted it through time, and it's different for men and women biologically. And so the one for women, we've got the BMR is 10 times your weight plus 6.25 times your height minus 5 times your age minus 161. And it's important that we get the units right for these as well. So weight is in kilograms, height is in centimeters, and age is in years. So if I were to put my stats in, it would look something like this. So I'm 55 kilograms, I'm 165 centimeters tall, and I am 28 years old. What? So let's substitute that into the formula. I've swapped pens because I'm sensing that there might be a space issue if I keep writing with the Sharpie. for this long formula, so hopefully you can still see this thinner pen. And I always really like to write the formula out again, because when I'm working through substitution, I want to know where it started. So I've got my formula again, and I'm just going to take each thing out individually and replace it with the numbers. So first of all, my weight, W, is going to come out, and in its place is going to go 55. So I'm going to end up with 10 times 55 plus 6.25 times 165, remembering that if you've got a letter and a number right next to each other, that is a multiply, minus 5 times 28 minus 161. Let's just slam that into a calculator, and that gives me 1280.25 calories. So if I were to do absolutely nothing, not walk anywhere, not do anything, and I wanted to stay exactly the same weight as I am right now, I would have to eat 1280.25 calories just to stay alive. Obviously, if you do some exercise, you need more calories on top of that as well. Okay, one for you to have a go at. So you'll probably figure out who this is, but the BMR is different for men slightly. So the BMR is 10 times the weight plus 6.25 times the height minus 5 times the age plus 5. And we're looking at Dwayne, who is 118 kilograms, 196 centimeters tall, and 47 years old. I hope you know who that is. And we need to find what Dwayne's BMI is. We'll compare it to mine as well. So, have a go. Again, I'm going to write out the formula just because I like to have it at the top of my sum. Okay, let's get all of the relevant information in there, remembering to times. Here's our sum, and we get 2,175 calories. So Dwayne "The Rock" Johnson needs to eat nearly double the amount that I do to stay alive and, you know, not gain any weight or lose any weight. Takes a lot to keep those muscles going. Okay, final one I wanted to show you is something that a friend of mine who is a nurse showed me. And this is the BMI, so different from the basal metabolic rate. This is your body mass index, and it's basically a measure of how much of you is made of fat. And I think a normal BMI is somewhere between 20 and 25, something like that. There's always a little bit of controversy around the BMI because most, you know, rugby players who are fit and healthy will have an overweight BMI, just because they weigh quite a lot, but a lot of it is muscles, so it doesn't really take into account, you know, muscliness. So BMI is not always a great measure of health for everyone, but it is useful to nurses who know what they're doing. So in this one here, for the BMI, we take the weight in kilograms and we divide it by the height, this time in meters squared. So my weight in kilograms would be 55, and my height in meters would be 1.65. So let's have a go at this. First, I'm going to write out the formula, then I'm going to do my substitution, just replacing the letters with the numbers. Oh, that's quite cool. It works out that my BMI is 20.20202020, repeating on forever and ever and ever. And the year is 2020. But unfortunately, I am no longer 20. That would have been real cool. It's worth having a go typing this into your calculator. It's worth having a go typing this into your calculator just to see if you get the same answer, because with the squared on the bottom of the fraction here, it can be really easy to accidentally square the entire fraction. It's just the 1.65 that's squared. Over here, my friend is a nurse and he works with a lot of amputees, and he told me that you need to keep a track of people's BMI when you're nursing, just to see if they're, you know, getting healthy or not eating enough, things like that. But it can be really difficult if someone is missing an entire limb or a part of them, because this formula will not work anymore for them. So what they have is a table of percentages, and it goes on, but I've just taken a few here. A table of percentages, which is the average percentage that a particular body part would take up of your entire weight. And to work out the estimated weight that they would be if they didn't have an amputation, they do their weight without the prosthetic divided by 1 minus the percentage, but that would be as a decimal. So this is quite a challenging question here. It says, find the estimated weight of a person who weighs 65 kilograms without their prosthetic for an above knee amputation. So first thing we do is we go to the table and we'd locate the above knee amputations. So that's going to be this one here, about 9.96% of their body weight. If I were to convert that to a decimal, you can do it in your head just now, it's going to be 0.0996. That is what we're going to substitute in for P here. So I will give you guys just a minute, and I would like you to try and work out the estimated weight of this person if they did not have their amputation. Okay, let's do it. So y'all know me, I'm gonna write out the formula again. Let's get the numbers in there and slam that into a calculator. And we can just do a little bit of a common sense check here. If this person weighed 65 kilograms with their amputation, would it make sense for them to weigh about 72-ish kilograms before they had the amputation? Yeah, I think that works out. Here's just a few examples of real-world formula that you end up substituting into. Using those formula. If you have any good examples of other real-world formula that you know, please fire them at me. I'm always collecting them. I would love to hear them. And thank you very much for turning up to maths class. I know it's a tough time, and you're doing the right thing. Well done.